What's a sequence? A sequence is a function whose domain is a set of positive integers. It also means an ordered list of numbers. So a sequence is infinite if its domain is a set of positive integers without a last term. For example, here we have a set of numbers. It has 1, 2, 3, 4, 5. The three dots that shows that the sequence goes on indefinitely. Although a sequence is finite if its domain is a set of positive integers that has 1, 2, 3, 4, 5 until n, which has a last term. Each number in a sequence is called a term. Example, here we have a set of numbers 5, 15, 25, 35, and 45. This is what we call terms. In the set of numbers, there's a first term, which is 5, the second term, which is 15, the third term is 25, the fourth term is 35, and the last and fifth term, 45. So, find the first 5 terms of the sequence whose general term is given by a sub n is equal to the quantity of n minus 3 raised to n. When we are substituting the first term, we are going to substitute it by 1. And with the second term, we will be substituting it by 2 and so forth with n. On the first term, we will all change the n to 1 since we are substituting the first term. Here is an example. A sub n is equal to n minus 3 raised to n. So, a sub 1 equals 1 minus 3 raised to 1. That would be negative 2 raised to 1, and the final answer would be negative 2, so that would be our first term. For our second term is a sub 2 equals 2 minus 3 raised to 2. That would give us negative 1 raised to 2, and the final answer would be 1. So that's how we find the terms. So let's do the rest of the terms. So the third term would be 0, and the fourth term would be 1, and the fifth term would be 32. Note that you can also use a scientific calculator for easier solving.
Arithmetic sequence. Arithmetic sequence obtain the term after the first term by adding a constant number called common difference to the preceding term. For example, given the number 6 and 9, what number can be added to 6 to have 9 as the sum and the second term? To get that, you'll find the difference of 9 minus 6, which is 3. So 3 will be the common difference. To finish it up, 12 comes next after 9, 15 after 12, 18 after 15, and so on. Another example. Given the number 25 and 22, what number can be added to 25 to have 22 as the sum and the second term? To get that, you'll find the difference of 22 minus 25, which is negative 3. So, negative 3 will be the common difference. To finish it up, 19 comes next after 22, 16 after 19, 13 after 16, and so on. Now, I'll teach you how to find the nth term of an arithmetic sequence. The formula to be used is a sub n is equals a sub 1 plus n minus 1 times d. A sub n is the first term, d is the common difference, and n is the number terms. Let's use the given example earlier. We'll find the 12th term of the arithmetic sequence, 6, 9, 12, 15, 18, and so on. A sub n will be a sub 12 since we're looking for the 12th term. Then, a sub 1 will be 6 since it is the first term of the sequence, times n, which is 12, minus 1, times d, which is 3, the common difference. A sub 12 is equals to 6 plus 12 minus 1 times 3. A sub 12 is equals to 6 plus 11 times 3, which will be 6 plus 33, which is equal to 39. So the 12th term of the given sequence is 39.
In this clip, we will be talking about the geometric sequence. Let us begin with defining the geometric sequence. A geometric sequence is a sequence whose term after the first term is obtained by multiplying a constant number by the preceding term. The constant number is called the common ratio. Basically, a geometric sequence follows a pattern of multiplying from one term to the next. A common ratio is a fixed number used to multiply the previous term by the next term. The common ratio is denoted by R. Here we have two examples of geometric sequence. We have the sequence 1, 3, 9, 27, and 81, which is the common ratio of 3 because 3 times 3 is equal to 9, 9 times 3 is equal to 27, and 27 times 3 is equal to 81. For the second example, we have the sequence 4, 28, 196, and 1372, which has the common ratio of 7. Now let us proceed with finding the nth term of the geometric sequence. Or to put it in another way, we'll search for a particular term from a given geometric sequence. The formula to be used is a sub n is equal to a sub 1 times r raised to n minus 1, where the a sub 1 is the first term, the r is the common ratio, and n is the number terms. Let's now apply the formula. Find the eighth term of the geometric sequence 3, 6, 12, 24, ellipsis. The value of the a sub 1 is 3 because the first term in the given geometric sequence is 3. The common ratio is 2, and the value of n is 8 because we're looking for the eighth term. Again, we're going to use the formula a sub n is equal to a sub 1 times r raised to n minus 1. After getting the formula, we're going to substitute the values. So a sub 8 is equal to 3 times the quantity of 2 raised to 8 minus 1. The first thing that we're going to do here is to solve the exponent. So 8 minus 1 is 7. So 3 times the quantity of 2 raised to 7. After solving the exponent, we're going to solve for what's inside the parentheses. So 2 raised to 7 is equal to 128. 3 times 128 is equal to 384. Thus, the eighth term of the geometric sequence is 384. And that is how you find the nth term of the geometric sequence.
The Fibonacci sequence. The Fibonacci sequence is a sequence of integers that starts from a 0, followed by 1, then by another 1, then a series of growing larger numbers, and continues infinitely. The sequence follows a rule that each number is equal to the sum of the preceding two numbers. For the first example, the first two numbers is 3 and 6. 3 plus 6 is equal to 9, 6 plus 9 is equal to 15, 9 plus 15 is equal to 24, 15 plus 24 is equal to 39, and so on. For the second example, the first two numbers is 4 and 10. 4 plus 10 is equal to 14, 10 plus 14 is equal to 24, 14 plus 24 is equal to 38, and so on.
Now let's discuss series. Series is the sum of the terms of a sequence, meaning it is the total amount or the total number of all the terms in a given sequence. For example, in an arithmetic sequence 5, 15, 25, 35, and 45, if we sum it all up, it would be 125. Therefore, the series or S5 will be 125 since the number of terms that we sum up is 5. But let's say, for example, in a given sequence earlier with 5 terms, we're only looking for S4, meaning we'll just sum up 5, 15, 25, and 35, which is 80. So S4 will be 80.